All right, welcome to a quick overview of statistics. The next unit you will cover. This is going to hit on all of the main topics we will cover and then some. You do not need to feel like you should take notes during this. This is just so you can kind of see the big picture of statistics. It is all about the data. If you've watched the media, the news, the sports channels, any type of information out there is all based on data. So the first steps are obviously the what, the who, and the how. Before you can do anything with data, you need to know what you're actually interested in getting data on. So there's usually a question of interest, and that question of interest is followed by who are you actually interested in knowing about. So you need to know who you're going to get this information on, and then you have to really think about how you're going to go about getting this information. And all three of these questions are usually left out when you look at the results of data, and it's too bad because they're critical in the actual data itself. So the what question you're interested in answering is sort of a personal question, and it comes about for many different reasons. But once that has been answered, you do need to look at the population of interest. A population is an entire group of people you're interested in studying, every single one of them. So the population of the United States is vast. And if I wanted information on every single person in the United States, that would be called a census, which is a timely topic coming up this year. If I realize I can't reach every single person in a group, which is very probable most of the time, you would then choose a subset of the population, and that would be considered a sample. You do want your sample to be representative of the population of interest, which means it should be free of bias, and bias we will talk about, but that's when your results from your sample are either over or understating what the true value or sense of the population would be. So if I'm interested in the entire high school and I wanted to ask every single student, that would be a census, and I would get information about everybody. That would be hard with 1,600 people, so I might rather choose a sample and maybe ask 100 students and get information about those 100 students and use that as information about the population. But it would be very important how I choose my sample. Randomization is key. You would like your sample to be free of errors, and that's kind of how you ask the question and the wording and all of those sorts of things. But the main techniques of sampling are convenient sample, which does not use randomization. It literally means whatever's the easiest. For me, it would be just asking my own students a question. A simple random sample is when every single person in the population has the same chance of being selected. It's an excellent technique. It also means every sample of the same size has the same chance of being selected. So if I wanted 100 students, and I did it with a simple random sample, all 1,600 students in the school would be assigned a digit, and then I would randomly select digits, 100 digits to use using a random number table, or your calculators actually randomize digits as well. Then I would have no choice in who I was selecting, and the sample would be done randomly. A systematic sample can use randomization, but that would be like where you just pick a number at random, again using other thing than just your brain, and then using that system. So if I picked a random number out of a random, even out of a hat, or a random number generator, and that number was 13, then every 13th student is who I would randomly ask. And it wouldn't really be random because every person doesn't have the same chance, but I'm not picking, it's the system that's picking for me. A stratified sample is when you break your population into groups and then choose a sample from within each group. For example, if I decided to break a high school into freshmen, sophomores, juniors, and seniors, and then randomly pick 25 freshmen, 25 sophomores, 25 juniors, etc. And a quota sample is a type of stratified sample where from within each strata, you are picking a proportionate amount that represents it. So if there were more seniors than freshmen and I did a quota sample, I would have more seniors in my sample than I would freshmen. All right, moving on. That's your first steps, very important, what you're going to do, who you're going to do it, and how you're going to go about it. The how can also include an observational study, a survey, a questionnaire. It can include an experiment. So there are a lot of ways to actually go about getting the data. And then once you've decided which way you're going to go about getting the data and who you're getting your data on, then you need to consider what is going on with your data. You want your data to be reliable, which means that if you were to sample again, say, your results would be similar. They will not be exactly the same, but you would expect them to be similar from sample to sample. And sufficient. Did you actually get enough data? If there's a high school of 1,600 kids and I ask 10 kids, I can't really use that 10 kids to represent the whole population because it wouldn't be a sufficient amount of data. And then once you've kind of decided if your technique in getting your data makes your data reliable and that you've collected the right amount of data, you're now dealing with what type of data do you actually have. And for IB, we're going to be looking at discrete and continuous types of data. They're both quantitative in nature, meaning they're both numbers. Discrete are numbers that can be counted. Continuous are numbers that cannot be counted, so you would have decimals and fractions and whatnot. So on the survey you completed just maybe moments ago, the discrete would possibly be how many siblings you have. You can have a half brother, but you can't have half of a brother. So you're counting siblings, 1, 2, 3, 4. Continuous variable would be like I asked you for height in inches. We are not all just 70 inches, 71 inches, 72 inches. Some of us are 70.5 inches or 70.25 inches. So those are continuous variables. Either way, one thing you can do with data is make a frequency table, which would be to list the possible values and then count how many times they occurred. It's different with discrete and continuous, and we'll look at that in more detail. But once you have your frequency table, you want to take a look at it and then consider the shape, the outliers, the center, and the spread, or check out your socks. And those three things are important, and it's also important to do them in that order. So once you have your numeric data in front of you, just piled up, you might want to look at it in a frequency table. Then you're going to want to consider the shape of it, which is looking at a graph. If you have discrete data, you are looking at a bar graph. If you have continuous data, you will be looking at a histogram. The difference is the discrete, the bars don't touch because there are no values in between. A continuous, the bars touch because there's a continuum of values that can happen in between. The first thing after you look at, decide which type of data you have, and then based on that, which type of graph to make, you want to consider the shape of it. Is it skewed or is it approximately normal? So skewed would be the two graphs on the left and the right, and they have tails. They're pulled one way or the other. The skewness is to the tail, so the graph on the left that says positive skew is actually would be also called skewed to the right. The graph on the right side, oddly enough, has a tail pulling to the left. It would be skewed left. The one in the middle is very symmetrical, and it is considered bell-shaped or approximately normal. If you have outliers, your graph will most likely look at the left or the right, and those are very important because they will dictate the shape, and they will also then dictate what values you use to describe your data. So the shape helps you lead to outliers. There are ways to calculate outliers. We will look at those. Once you have determined the shape, and that must come first, if it's skewed and you want to talk about the middle or the central tendency of your data, you would use the median. So the graph on the left and the right, you would use the median to talk about the center. If your distribution is symmetrical or bell-shaped or approximately normal, those all mean the same thing, you're going to use the mean to calculate the center of your distribution. And we will spend time talking about how to calculate both those. But the important thing to take away from this is depending on the shape dictates which measure of center you use. And the shape dictates the center, which also then dictates what you use to measure the spread or dispersion. So if your data is skewed, you must use the median, and then your spread or dispersion, how wide your data is, would be calculated by the range or the IQR, which stands for interquartile range. If your data is symmetrical or approximately normal, you would use the mean, and if you're using the mean for center, the measure of spread that goes with that is the standard deviation or the variance, and those two are basically related to each other mathematically, so it doesn't really matter. But very important, median, IQR, mean, standard deviation. You don't flip-flop those around. They go together forever. And finally, once you have determined all of that information, we won't get to it in this course, but in other statistics courses, your final steps, once you had your data and looked at it and looked at numerical summaries of it, center and spread, you would use that to make some sort of decision to answer the question you originally had about your population. And you would either use confidence intervals or hypothesis tests to do that. And then that is the power of statistics, is using a small amount of data to answer a very large question about a very big group of people. And you see it all the time in the news, especially nowadays. And it's very important to not just understand what those numbers are telling you about the population, but to think back to the beginning. How did they decide to collect this data? And that method, if not done properly, means all of your numeric results are meaningless. So there's your introduction. We're going to delve into many of these topics in detail over the next little while. I hope you enjoyed it and have a wonderful day.